Find the dimension of the rectangular corral producing the greatest enclosed area, split into 3 pens of the same size, given 500 feet of fencing. The first step in solving any word problem is to see if we can draw a diagram. In this case, this corral has a shape of a rectangle. We then divide this rectangle into 3 equals pens of same size. 1, 2, and assuming that these 3 has the same size. If we let y be the height, then this is also y, this is also y, this is also y. And if we let x be the width of each of the pen, then this is x, this is x, this is x. We are given only 500 feet of fencing, meaning we would have to use 500 feet for all of these line segments here. At the bottom, there are a total of 3x, and on the top, we would need to fence the total of 3x, and there are 4 vertical lines, each has a length of y. And so the total distance that we would have to fence is 3x at the bottom, 3x at the top, and 4y. And the total of fencing is 500. This is what is known as the constraint. This is the restriction on x and y. Simplifying this, we have 6x plus 4y equals 500. But the question is asking us to find the greatest enclosed area. When we hear the word area for a rectangle, then we should be ready to write length times width, or in this case, length times height. The length of the rectangle, the big rectangle enclosed, is 3x. 1, 2, 3. And the height is only y, not 4y, because this is the length and this is the height. The area is now 3xy, which is an equation in 2 variables. We would need to get rid of one of the variables, and that is where this constraint kicked in. Using this constraint equation, we will isolate y by first 4y equals 500 minus 6x, and so y equals 500 minus 6x over 4. We can substitute this with y, and so the area is 3x times y is now 500 minus 6x over 4. We will need to simplify this in a minute. Simplifying this, we have the area equals 3 over 4 x times 500 minus 6x. Multiply this out, we have 1500 over 4x minus 18x squared over 4. And this is a equals 1500 divided by 4 is 375, and 18 divided by 4 is 9 over 2. This is a quadratic equation, and it represents the area. To find the largest area is to find the maximum of this function. And we don't really need to do much, because we know that this parabola has the coefficient a equals negative 9 over 2, and b equals 375, c equals 0. In the standard form, this is y equals negative 9 over 2x squared plus 375x plus 0. This parabola, its graph is concave down, and so it has the maximum. The maximum occurs at x equals negative b over 2a, always, if the graph concaves down. In this case, we would rewrite negative. B is 375 over 2. A is negative 9 over 2. Simplifying this, we have x equals 375 over 9. This is 125 over 3 in decimal. This is 41.67, and the unit is feet. And so for this rectangle, the length is not x. The length, remember, it was 3x, and this is 3 times 125 over 3, which is 125. The unit is feet. To find the height, remember that we denote the height by y. The height is y equals 500 minus 6x over 4. This is 500 minus 6. Remember that x is 125 over 3. Divided by 4, and so we get 62.5. The dimension of this rectangle that guarantees the largest area is 125 feet by 62.5 feet.